Alright, hello everyone, my name is Timothy Lee Grant, and yesterday we were trying to solve an easy linked list problem, and I was not able to quite do it. So let me minimize myself here, and we're going to try it again, and we'll see what happens. There we go, and I'm just going to, should be a reset. Here it is, okay, reset this. Reset. There we go. Okay, so we're trying to merge these two linked lists, and they are sorted. So each list is sorted, and we're trying to merge them together. So let's see, we're going to come here, and how do we want to do this? I was thinking that we are going to need to the way that I'm going to do this problem is I'm going to first try to attempt to do it myself, and then if I can't get it myself, okay, then go look at the solutions. I was hoping that today, because I'm a little bit less tired, yesterday I was pretty tired. Today I don't feel tired, so I don't have any excuses. I don't know, but yeah, I was hoping that today when I started this video that, it was just going to come to me, and I was going to be like, oh yeah, I know how to do this, but then not so much. Okay, so I know that I'll need to iterate through each of these, so I need a pointer to like where I am in each of these lists. I know that I also need something like a head, so I'm gonna have like head is equal to, and then I'm gonna do this create a list node like this. Okay. And then maybe I just do null. Is equal to 0. Okay, whatever. So if not list1 return list1 and not list2, then what do we want to do? We want to return just an empty list, okay? So now I can say if not list1 return list2, if not list2 return list1. Okay, so now we know that we have something in list 1 and list 2. Okay. So now what I want to do is while list 1 and list 2, I don't know if that's correct, but I'm going to say, so while both of them are legitimate, I am then going to, hold on one second, let me see what it said here. All right, there we go. Just responding to someone. Susie sent me a message. She's out, went to this like German town in Washington. I think it's Leavenworth, something like that. Anyways, so list 1 and list 2, I know that both of them exist. Okay, so now I need to check which one is smaller. So if list1 dot val is less than list2 dot val, okay, then I want to say how do I I need some way to traverse it though, right? Hmm. And then I'm going to say traverse is equal to 0 as well. Okay, so I'm going to say like this, and then I'm going to say if not head, okay, then I will assign head is equal to this list value, this one, list, no, I need to be creating a new list though, don't I? Or a new linked list. So head is going to be equal to list node with list one dot val. Okay. And nothing as the next yet, because I'm gonna assign that. Okay. And then I'm gonna say traverse is equal to head, like this. Otherwise, what I'm gonna do, else traverse dot next is equal to list node list one dot val. Like this. I don't think I'm on the right track. I don't think I'm on the right track. If not head, so, greasy. There we go. I was trying to figure out how to spell that word. All right. Okay, so traverse dot next. I don't think I'm on the right track. All right, so I'm just gonna go here. Okay, so we failed to be able to actually do it, but now I'm just gonna come here and see, like, do an autopsy. Okay, so let me make some notes. How do they do it? If not, okay, so I did this correct, I did this correct. Okay. They do recursion? Oh, no, I don't want to do recursion. So they have dummy equals node equals list node. Okay, so they just created some dummy variable. I don't know why. And then they also did this thing here. The same thing that I did, okay? node.next is equal to list1. So this dummy node. Oh, and then they just return dummy.next. Okay, I see. I kind of see how this is going. So are they doing things like... And then, so they're not creating a new linked list each time. They are just weaving this list, essentially. So first, node.next, and then they move the linked list because it doesn't matter. So this is the pointer to like where we are. So they don't have this traverse, they just have node. Node is kind of like traverse, actually. So traverse.next is equal to here. Okay. Where is node changed? Oh, okay. So then, oh wait, no. Is equal to the what I just assigned. So then it's going to, we're going to update it and it's going to become list1. Okay. So let me see if I can go like this and redo this. So apparently we don't even need this. So let me just come here and just delete all this. And from memory, dummy is equal to node is equal to list node. Okay, and now I want to do while list1 and list2. Okay. If list1.val is less than list2.val, then what do I want to do? I want to assign my node equal to this one. Node, that's like traverse, dot next, was it node dot next is equal to list1. Okay. And now list1 is equal to list1 dot next, like this. Otherwise, we're gonna use we're gonna swap that. So node dot next is equal to list2. List2 is equal to list2 dot next. Okay. And now we should move our node, our traverse. So node is equal to node dot next, like this. And now, once we're done, I should say if list1 node dot next is equal to list2 lf list2 node dot next is equal to list. Oh wait, no. If list1, I want to do list1. Do this one. Okay. So now I want to return dummy.next, right? Let's see if it works. I don't know. Okay, so it did work. obviously I need to do this problem again tomorrow, and I need to kind of let this settle in my brain about what's happening. Let's see. So if I have my node next, so this is kind of like the traverse one, and I'm weaving them in, so I'm not creating a new list here. Okay. And in this case, I'm just going to look at this case. Let me submit it, make sure it works. Okay, cool. So in this case, node.next, so traverse my current, the pointer to where I'm currently looking. Dot next is list one. And I'm like behind the thing or something. What I mean, what? I'm trying to think about how to visualize this here. Because I'm always behind one, right? Like this dummy is behind one. First it's nothing, and then once I find nothing, I set nothing's next equal to this one. So then the next time I'm actually on the first one, even though I'm looking at the second one. Okay. So I create a new one like up here. Okay. So I create a new one up here, and then I have, let's just say that I take this one, okay, so I have the one right there, and I connect it, and then, so node is pointed to this dummy up there. This is a dummy, okay, this is one. And now what I can do is list one equals list one dot next. So this one has a like next, and so here's traverse, and here is what? This is this list one, L1. So then I move it over to the next. So now it's like that, okay? Then I go again. Or then I move my traverse to that one where list one used to be. Yeah, see, that's what I mean by it's one behind. Now I move it to where it used to be, okay? And then, if I find another one, yeah, because list one is now pointed ahead by one, okay? And then I come back up here, and list one is still there. So I come back in here, and then I can do node.next, which is this traverse one dot next is equal to where I'm currently looking at. This let's just say I have this one, and this one is like 10 or something, like it's big. So I'm going to select this one again. So then I say like this is a candidate, and this is a candidate, and that's kind of like this list one is a candidate. Okay, so while I still have a candidate, maybe I can say that, while I still have a candidate, I look at my candidate's values, okay, and then I look at my traverse values and assign it to that candidate, and then I move the candidate to the next one because I just used it. Okay, there we go. I think I'm starting to see that. Okay, and then I move my node up by one to itself. So I said like my own, the one that I just selected as the candidate, I move to that because that's the end. This is the tail essentially. And then these make sense. Like if I still have any candidates in list one, if I don't have candidates in both of them, but I do have candidates in list one. That means all of my remaining candidates are in list one, so I just put that as the rest. Okay, I kind of understand this one. I'm gonna try to do it tomorrow, and I want to get to the point where I can do it pretty quickly, and just understand what's going on. I think I need some time to process this a little bit more, but funny enough, like I avoided doing the linked lists problems because I thought that I had a good understanding of them. Because when I did like that, whatever, the sophomore level algorithm or data structures, they separated it. Data structures, and then they had another one which was algorithms. So when I did my like 200 level data structures course, I was thinking, I did pretty reasonable on the linked list, but that was a long time ago, right? So now when I saw the roadmap, I was like, oh, okay, linked lists. I'm gonna avoid linked lists. I don't need to study. Not that I don't need to study it, but I was like, the other ones had higher priority because I thought that linked lists were going to be a breeze. Apparently, they are not a breeze. But yeah, so anyways, we're gonna keep going on these and try to understand things better, and hopefully, yeah, I definitely need to study linked lists more than I anticipated. So that's what we're going to be doing. Anyways, thank you guys for watching this video. If you want to follow along on this journey, subscribe. I would love to have you along with me. So yeah, thank you. My name is Timothy Lee Grant, and I will see you guys tomorrow.